An equation of a circle in standard form is x minus h quantity squared plus y minus k quantity squared equals r squared. H and k represent the coordinates of the center of the circle, and r is the length of the radius. Notice that the equation gives us r squared. We'll need to take the square root of this value to find the length of the radius. Where does this general equation come from? Let's name the center of the circle hk and a point that lies on the circle xy. The distance between them is the length of the radius r. Now we'll create a right triangle with hypotenuse r, and we'll let the two legs of the right triangle be a and b. Using our favorite Pythagorean theorem, we'll write down a squared plus b squared equals c squared. We'll let x minus h represent the length of leg a, substituting it into the Pythagorean theorem. Then we'll let y minus k represent the length of leg b and substitute that into the Pythagorean theorem as well. Finally, we'll plug in r for the length of the hypotenuse. And that's how you derive the standard form of an equation of a circle. In example 1, we're going to write an equation of a circle with a center at 3, -2 and a radius of 4. We'll substitute the coordinates of the center, h and k, into our equation, and then also substitute the value of the radius 4. We'll simplify the final answer by eliminating double signs and squaring the value of r. In example 2, we're given a center at -4, 0 and a diameter of 10. Since the diameter is twice the radius of a circle, we'll divide by 2 to find the radius, 5. We'll then substitute the values of h and k into the equation. X minus -4 squared plus y minus 0 squared equals 5 squared. After that, we'll eliminate double signs and square the radius to write the equation of the circle. In example 3, we're given a center at 2, -9 and a radius of radical 11. Substituting these values into our equation, we get x minus 2 quantity squared plus y minus -9 quantity squared equals radical 11 quantity squared. The square power and the square root are inverse operations and eliminate each other, giving us x minus 2 quantity squared plus y plus 9 quantity squared equals 11. Because the standard form of an equation of a circle has x minus h and y minus k, the values of h and k are the opposites of the signs that you see. We'll find the x-coordinate of the center grouped in the parentheses with x, and the y-coordinate of our center grouped in the parentheses with y. This will be our center hk, 6, -3. Remember that the signs are the opposites of the ones that you see. The equation tells us that r squared equals 25. Take the square root to find that your radius is 5. We can also find these pieces of information by looking at the graph. The center of this circle is at 0, 0, and the length of the radius is 12. We can substitute these values into our equation, x minus 0 squared plus y minus 0 squared equals 12 squared, and simplify to write the equation of the circle. Pause the video now and try example 6 on your own. Identify the center of the circle, making sure that you count in each direction from the center and confirm that the radius is equal in all directions. This is correct, so the coordinates of our center are 1, -3. The final answer is x minus 1 quantity squared plus y plus 3 quantity squared equals 49. In this equation, we're going to identify the center and the radius of the circle from the equation and then graph it. The center is 3, 2, and the radius is 3. Plot the center on the graph and then count 3 units in each direction, right, up, left, and down. Then draw the circle.